Hey everybody, Mr. Beckstrom here. Today I wanted to take a look at an example of right triangle trigonometry. Here's a word problem, and I want to see about how we would go through the steps of solving this. So here it is. A security camera in a neighborhood bank is mounted on a wall 12 feet above the floor, and it says what angle of depression should be used if the camera is to be directed to a spot 6 feet above the floor and 20 feet from the wall. So in any problem like this, a word problem, the first thing I always like to do, and a lot of instructors will suggest that you do, is to go ahead and draw it out to the best of your ability. And that'll kind of give us a good idea of uh, the triangle that we're looking at, and it'll be able to kind of give us a good visual of what angles or sides that we're trying to find. All right, so kind of going through here, it says it is mounted on a wall 12 feet above the floor. So first thing I'm going to do here is draw my wall, and I'm going to put a little camera, right? It's 12 feet above. So I know that this distance here, let me try to make that a bit straighter. Well, it's all right. Freehand that to the best of my ability. But I know that that right there is 12 feet. All right. Now, angle of depression, we're going to see this sometimes, angle of depression or angle of elevation. And that is an angle coming off of a horizontal line. Let me just kind of do that up here. So if you have a horizontal line here, an angle of elevation is the angle that comes above it, and an angle of depression is an angle that goes below it. So you always start with the horizontal line, angle of elevation goes above it, angle of depression goes below it. So they're talking about an angle of depression here. So let's say we've got, change the color a little bit, we've got this horizontal line coming out here, going this direction here, and they're saying what angle of depression, so that's going to be going down, and we're going to go 6 feet above the floor, so we're going to end about half the distance above the floor, and we're going to end out 24 feet from the wall, so about twice this distance from the wall. So if I go out 1, 2 distance, about halfway up, so we're probably going to end about right here. So if you want to kind of start here, that's going to be like maybe something like this, and then you're going to go straight up there. So here is our triangle. It looks like it's going to make a right angle right there. So if I want to go ahead and use my ruler and try to kind of approximate that right triangle outside of that, it's going to look something like this. So I've got that. I've got, I wish this tool was a little bit faster, but here we are. I've got a straight line that comes down a little bit. And I probably should have done that one next, but right, there we go. And one last line that goes like so. All right. Connect it there. Okay, so we got a triangle that looks like this, and let's see what lengths that we know. We know that, back up here a little bit, we know that this distance from there to there is 6 feet, because it tells us, go out a little bit, tells us that 6 feet above the ground, so that means 12 minus 6, so this distance here is going to be 6, right? And we also know that this is 24 feet, right? Because it's 24 feet away from the wall, so this is 24 feet. And the angle of elevation, excuse me, angle of depression, this is the angle that we're trying to find right there. So whatever you want to call for that, I'll call it alpha in this case. So We'll call that alpha. So we're trying to find alpha, and we know that this side here, and we know this side here, and we know that this here is a right angle or 90 degrees. All right, so now that we have our triangle kind of identified, located, and we know which angle we're trying to find, and we know what sides we have, this is where we're going to pick which of the 6 trig functions that we want to use. And there's 2 that we can use since this is our acute angle that's in play. Remember, this would be our opposite side, this would be our adjacent side, and this would be our hypotenuse. So the 2 trig functions that use our opposite and our adjacent would be either tangent or cotangent. And I mean, the easier one to use would just be tangent, because that's our 3 basic. That's one of our 3 basic trig functions. So we know that the tangent of an angle is equal to the opposite side over an adjacent side. That's from the chapter or section we've been reading. So in this case, the tangent of the angle that we don't know yet is equal to the opposite side, which is length 6, over the adjacent side, which is length 24. So we know that the tangent of this unknown angle is equal to 6 over 24, or 1 over 4 if we wanted to reduce that. We don't really need to, because we're going to end up using our calculator. Now, one thing that hopefully we've learned in our section here is that we need to isolate this angle here. And the way that we do that is we apply the inverse trig function to both sides. In this case, it would be the inverse tangent to both sides. So applying the inverse tangent to both sides, the inverse tangent of the tangent would just leave us the alpha on this side. So if we apply the inverse tangent to the tangent, that'll just leave us alpha. And on this side here, we're going to get the inverse tangent, because we're applying the inverse tangent to both sides. The inverse tangent looks like this, tangent to the -1 of 6 over 24. All right. And they're asking us the angle, and normally when we give an answer in an angle, we normally give it in degrees unless they specifically ask for it in radians, but they usually want it in degrees. So when I open my calculator here, which here should have these standard keys if you're using a TI-83 or TI-84, here's a TI-84. I'm going to first go to mode and make sure that mine is in degrees, because if it's not, it's going to give me an answer in radians, which is going to look much weirder. It won't give me a good degrees. And looking at this, since this side is so much longer than this side, I should get a relatively small angle here. So if I end up getting an angle like 45 or 60, I know I probably did something wrong. So I'm looking for a small angle, maybe 10 or 15 degrees, but nothing real big. So let's go ahead and put that in there. So we're going to do the inverse tangent. So the tangent key is here. The inverse tangent, it's hard to see in this video, I'm sure, but it's the blue here right above the tangent. It says tangent, and that has a little -1 in the upper right hand corner. So to do the blue part, you're going to hit the second tangent, and that does the inverse tangent here. And then you're going to do 6 over 24 or 1 over 4 if you reduced it. Either one is fine. You don't have to reduce it here. I'm just going to put 6 over 24 and enter. And this is the degrees. So in this case, I'm going to, usually when we do these degrees, we round them to 1 decimal place. So that would be 14.1. So in this case, it would be alpha is equal to 14.1 degrees. And that would be your answer. So the angle of depression For this camera here, that's the angle that it swings down from that horizontal position, would be 14 degrees from the horizontal. All right, I hope it's made some sense. If you have any questions, let me know, and have a great rest of your week. Thanks.